Alright, ladies and gents, here we go. I'm going to talk through your Radicals review, and I hope you French friends had fun at your field trip. And I hope that many, many, many of you are watching this. But, Radicals review, we need to review and go through the things that you need to know for your summative. So, I'm going to talk through it one by one, and yeah, we'll see how you feel at the end of this. Alright, make sure that you have tried these before you watch the video. It's not very helpful for me to walk you through everything and hold your hand through everything, especially since I can't hold your hand through the test. So, this first question is asking for the distance. So we need to use the distance formula, which is the square root of x2 minus x1, so the distance between your x's squared, plus the distance between your y's squared, all of that underneath the square root. So I'm going to name this one x1, y1, x2, y2, and we'll go from there. So x2 square root 8 minus x1, 3 squared, plus y2 minus y1, which is a negative, so that'll be positive. Alright, so we get the square root of 8 minus 3, which is 5 squared, plus 6 plus 6, which is 12 squared, which gives you the square root of 25 plus 144, which gives you the square root of 5 and 4 is 9, 4 and 2 is 6, 169. Okay, and if I remember right, let me check my calculator, but I believe, so, square root of 169, whoa, and we get 13. So there's your answer. Alright, so we need to talk through number 2. So, number 2. 3, 4, 2, 6. So same deal. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So, square root x1, y1, x2, y2. I just like to label them so I don't lose track. Might be good practice for you if you tend to see yourself losing track. My x's squared plus my y's squared. So I get 2 minus 3, which is 1, squared is 1, plus 6 minus 4, which is 2, squared is 4. So my distance is the square root of 5. Not too bad. Alright, that's my final answer. Okay, so if I keep moving, midpoint formula. So I'm going to write that off to the side. It's real easy. You add up your x's and you add up your y's and you divide them each by 2 to average them out. So if you want to name them x, y, and x2, that's totally fine. Not a big deal. So if I do that here, 7 and 3, oops, not times, plus 3 over 2. And y plus y is 5 and 1 divided by 2. 7 and 3 is 10 divided by 2 is 5. 5 and 1 is 6 divided by 2 is 3. Wham bam. Next one. Add up your x's. Remember to keep that negative in there. Over 2. You don't really need the parentheses there. Don't worry about them. But you do need the parentheses around the whole thing because it's a point. So it has to be in coordinate form. Negative 6 plus negative 4. I don't know what I'm doing, putting all these extra things in there. Don't need that there, but it's there anyway. Divide by 2. So we get negative 3 plus a negative 1 is negative 4. Divide by 2, you get negative 2. Negative 6 plus negative 4 is negative 10. Divided by 2 is negative 5. Now it makes sense that my midpoint is negative in both x and y's, because if you look, my x is negative, my y is negative, x is negative, y is negative. That means my 2 points are both in the negative area of my coordinate plane. So, if 2 points, this one, maybe this point, and this point, are in the negative, then their midpoint should also be in the negative. Okay, simplifying radicals. So, 128. So we need to figure out what sort of perfect square radicals or perfect squares that has. So, I know that it's divisible by 4. 108 divided by 4 is 32. So I plugged it into my calculator. So 128. Oops, I don't need to write that. It's already written. So I'm going to say the square root of 32 times 4. Now I know that the square root of 4 is 2, which leaves me the square root of 32. Now, when you do that, you have to go back and think and check again if there are any more perfect square factors of the number under the root. And there are. 32, you can break that up into 4 and 8, with that 2 on the outside. So 2 times square root of 2 is 2, or square root of 4 is 2, right there. And square roots of 8. 2 times 2 is 4, square roots of 8. 8 can always be simplified if it's under the square root. 4 times 2. So I'm going to pop out even another one. That's going to be 2 times 4 square roots of 2. 2 times 4 is 8, so it's 8 square roots of 2. Alright, scooting over here to 6. You know that you can't have a fraction in your square root, so I'm going to give the square root to the top, give the square root to the bottom. Square root of 25 is 5, square root of 36 is 6. That one is pretty easy. Still chugging along. So I know I can't have a fraction in my square root. So I give the square root to both the top and the bottom. Now I need to simplify. So 12 can be divided up into 4 times 3. 75 can be divided up into 25 times 3. So I'm going to have 2 square roots of 3 over 5 square roots of 3. Now, in this case, you have to check for this, otherwise you are oversimplifying. Multiplication, multiplication. There's multiplication in between each piece. So, cancel, cancel. In the end, I will get 2/5. Okay. Number 8, 3 square roots of 12, or 4 times 3, all over the square root of 6. Now the square root of 6 cannot be simplified, but I know that I cannot have that square root in the bottom. So I'm going to multiply by that on the top and the bottom. Okay. So, instead of actually doing this part here, I'm going to leave that out until after I multiply here, because otherwise I'm going to have to multiply by a lot. So I'm going to leave that there. Okay. So, square root of something times the square root of that same thing is underneath the square root. And then I have 3 square roots of 72 is 6 times 12. Go back to your rules of multiplication if you don't see that, my friend. You've got a 12 underneath and a 6 underneath, so you multiply them underneath. Okay, you can think about that with this even too. If you've got those two things being multiplied underneath, you get 36 square roots. So that does give you 6 in the end. So hopefully you'll see that. Alright, 72, I can break that up. 36 times 2 over 6, which gets you 3 times 6 times the square root of 2 over 6. Now I've got a multiplication, multiplication, multiplication. The only thing is that dividing line that isn't multiplication, so I'm going to cross out those 6's. I get 3 square roots of 2. Okay, scooting over to number 9. 60 times 5 is the square root of 300. And if I divide that up, 100 times 3. The square root of 100 is 10, and the square root of 3 hangs out underneath. Alright, 5 square roots of 7 squared. Now, it is up to you how you think about this, but I would be very, very, very careful. Okay? When you are squaring something, that means multiply it by itself. So, multiply the numbers, 5 and 5, 25. Multiply the square roots. Square root of 7 times the square root of that same 7 is just that underneath the 7. So, it's 175. You could also think about it like this. I'm going to cover up our work that we did there. If you have 5 square roots of 7 squared, you could give the squared to the 5 and give the squared to the 7. That is also an option, and you'll still get that 25 and the 7. So, those are your two options for that. Okay. Alright, next. Oh my goodness. Not really sure why that's following me around. Okay. We'll just ignore it up there. Alright, first things first, we've got a number outside, and we've got addition in the middle, so we need to distribute. Alright. So, first your numbers. You've got an invisible 1 over here. 1 times 4 is 4. Square root of 2 times the square root of 6 is the square root of 12. Plus 1 times 1, you'll just have that 1. Square root of 2 times the square root of 5 is the square root of 10. Now, I know 4 square roots of 12 can be reduced because I've got 4 times 3 underneath there. I'm going to get rid of that 1 because it doesn't really need to be there. So I'll have 2 times 4 times the square root of 3 plus the square root of 10. 2 times 4 is 8. Square roots of 3 plus square root of 10. Factors of 10, 1 and 10, 2 and 5. None of those are perfect roots. So square root of 10 is as simple as it gets. Okay. Maybe I'm doing this wrong in some way. Alright. So, that's that. Not really sure why we can't just get along. Alright. Adding and subtracting. Well, since it's adding and subtracting, and you can't add or subtract these because they are all different square roots, you might think, oh, maybe I should simplify. You should think that. Okay, 45 is 9 times 5. 80 is 16 times 5. And 500 is 100 times 5. If you see something consistency like that, 5, 5, 5, that might be a hint to you of what you should look for to divide by. Square root of 9 is 3, square roots of 5, plus square root of 16 is 4, square roots of 5, minus square root of 100 is 10, square roots of 5. 3 square roots of 5 and 4 square roots of 5 is 7 square roots of 5, minus 10 square roots of 5 equals negative 3 square roots of 5. Remembering that this is very similar to adding variables. 3x's plus 4x's equals 7 of those same x's. And if you take away 10x's, you get a negative 3 of those same x's. Or values, depending on how you think about it. Okay. You can solve rational equations. Yes, you can. I think these are some of the easiest equations you have solved, judging from the feedback from many of you. Okay. Get the radical by itself. You cannot let that x escape until you get the radical by itself. 3x plus 4 equals 10. Squared both sides. 10 squared is 100. Is just the inside, because the square root and the squared will cancel. Take away 4. 96 equals 3x. And if I divide by 6, or divide by 3, sorry, I will get 6 divided by 3, 2, 9 divided by 3, 3. X equals 32. Now, what is the most important part of solving rational equations? Plugging it back in. So, you need to check your answers. The square root of 3 times 32 plus 4 plus 1 should equal 11. 3 times 32 is that 96. Plus 4 square rooted plus 1 equals 11. Square root of 100 plus 1 equals 11. 10 plus 1 equals 11. 11 equals 11. It works. So yes, that is my solution. Alright, next. I need this radical right here by itself. So I'm going to subtract 5 because this 5 doesn't have a negative in front of it. It's positive. Subtract 5. Then this negative comes with square root 4x minus 3 equals a negative 2. Now in order to get rid of a negative in the front, it's being multiplied, so why don't we just divide by it? So we get 4x minus 3 underneath the root is 2. Squared both sides, you get 4x minus 3 equals 4. Add 3. 7 divided by 4. You get x equals 7/4. Alright, so we're going to plug it in and see. So, we've got 5 minus the square root of 4x minus 3 equals 3. So 5 minus the square root of 4 times 7/4 minus 3 equals 3. So 4 times 7/4, those 4's will cancel out. 5 minus the square root of 7 minus 3. 7 minus 3 is 4, square rooted is 2. 3 equals 3. We are good. Alright, so there's some stuff that kind of got all over the place for whatever reason. Try and put it back where it belongs. Alright, but overall, this is how you are going to do your problems. This is how you're going to work through your problems. This is the stuff that is going to be on your test. So, whatever you need to do to review, please do so. iExcel is totally an option. And here are the sections. So, for radicals, performing operations, adding and subtracting, multiply, simplify, those sort of things, it's going to be EE. And most of those are the radicals. If you want to solve a radical equation, that's a different one. So that is the FF section for solving. Okay, and if you are looking for formulas practice like distance and midpoint, that is in the G section. Distance and midpoint is in the G section. It's G.2 for midpoints and G.3 for distance. So IXL is an excellent option for reviewing. If you have any questions about any of this, please come and see me. I will also be making a review video of the review that I will be showing you in class, the review notebook. So, good luck. I hope you guys, hope you guys have watched this, and if you do watch this, thank you so much. You're my favorites. Okay. Good night.